Nathan?
So I can still hear your audio on your end. So.
I got you. Okay, I took a look at what you sent me as a solution for that rectangular box problem.
Yeah, so it looks like they made some assumptions.
Well, they did exactly what we did.
Uh-huh.
Notice that my three equations were these three equations. The only thing is,
right.
They used X, Y, and Z. They use height, length, and width.
Right.
The reason I don't use height, length, and width is because what's depth? When I think of a rectangular box, I think of height, width, and depth. So it's always a little confusing when you use height, length, width, and depth. As you know, those are only three dimensions. So I just use X, Y, and Z. But here's what's strange. And that is that they act like that is trivial.
Right. They say, you know, the width is 3, the height is 4, and the length is 12. We're making the assumption that the width is...
Well, no, they got that by solving those three equations. Whenever you have three equations and three unknowns, you can solve it. And they did. It's just not trivial. In other words, they don't give you how they solved it. Perhaps they're expecting you to put it into Wolfram Alpha or some calculator and just let it solve it for you. And I'm sure that there are apps that will do that. Right offhand, I don't know how to do that on Wolfram Alpha, but I'm sure that you can put in three equations and come up with the solution without difficulty. However, recognize that that's not trivial. That's a 10-minute exercise, as you saw yesterday when I tried to do it. All of a sudden, I'm looking at a quartic. Okay. And then finally, the last step is also exactly what I did, which is to say that one dimension squared plus another dimension squared plus the third dimension squared is equal to the diagonal squared. In other words, I had the diagonal being the square root of x squared plus y squared plus z squared, which is that same thing.
Right. And that the square root would obviously arrive at the 13 anyway. So that, I think, is more correct than what their answer was.
Well, not necessarily, obviously. I mean, it's weird when you take three numbers and you square them, and then you take the square root and you get a perfect integer. That's fairly unusual. So in looking at this problem, I would not expect an integer answer. But it turns out that they set it up so that it would be an integer answer. The only thing they really don't explain is how they get that. And like I said, that's tough. I know how to solve three equations with three variables, and I'm happy to go through it with you. The problem is that it's like a 15-minute exercise. I mean, if I came up with three equations and three variables and solved it, I would show you exactly step by step how you could do it, but it's a very long exercise.
I think for the purposes of the test, I mean, I think this is the only, diagonal calculation or even volume of a cube calculation we have in the study guide. So quite frankly, I don't think it's really that highly tested.
I agree totally.
And
this is a ridiculous question.
Yep. And if I miss this and only need a 50% to get credit, then forget it. Yeah. As long as I'm doing well on the rest of the stuff, I should be just fine.
This is not a question that I would expect to see on any test of any student I've had in the last 10 years.
Okay.
It's that.
Well, that's good. And
difficult.
You know, and I have found that with these, I've used this particular service for these. This is the only place you can get the study guides. And I found that sometimes the study guides really aren't that great. And the testable subject matter may not even be on those tests, so you've got to do a larger review. But I think what we're doing here is going to be sufficient.
Okay, well, I'll help you wherever I can. But I got to tell you, the terminology they use, it's like when they talk about a complex number. Well, I've been teaching high school and college math for 10 years, and the only thing I've ever heard of is a complex function. Or, excuse me, a composite function. They had a question about which is a composite number. Well, I suppose a composite number is the number that you calculate from a composite function, which is how we got the square root of 36 on that one. But still, that's pretty strange terminology. Yeah.
Right.
This one here, what's a composite number? Well, they should at least start you out with what's a composite function.
Right.
We did that one. We haven't done this one. Let's see.
Well, and I know, too, a lot of math books will have a table if they have composite numbers in there.
Really? Okay. I've never seen such a thing. Yeah, no. A composite function makes total sense to me. I'm not sure why they have a category for composite numbers. I suppose that there are certain numbers that can only be gotten from a composite function. All right, I think we left off at this problem here. And
yep, you're right.
I mentioned, we talked about the log answer. You said that there were 3 or 4 log questions in here.
Yeah, as we get to them, between the two study guides. But I have clarification on that now.
Okay.
10 to the second is.
I can give you a quick, let me just give you a quick 5-minute tutorial on logs.
Okay.
Okay. Most of what you are looking at are algebraic equations. In other words, you're looking at something like this. Okay. That is an algebraic equation because the variable x is on the line. I can solve that algebraically.
Mm-hmm.
But if we have a function like this, where the variable is in the exponent, that is not an algebraic expression. That is an exponential expression. If I told you 8 is equal to 2 to the x, it would be quite easy to figure out that x had to be 3, right?
Right.
But if I told you 7 was equal to 2 to the x, you would have no algebraic way of solving that. Because it's some number between, it's not 2, it's not 3, it's between 2 and 3. But how to figure it out, you need a calculator, and thus that's why they invented logs. Okay? So, when you start with an exponential expression, there are actually 2 ways to express that. One is the way I've done it, but another is to realize that logs are exponents. So if I say the log base 2 of y equals x, logs are exponents. The exponent was x. So this log expression with base 2, because that's what the x is raising is the 2, is equivalent. Okay? So let me write it. That's the equivalent expression. And that is about all I want to teach you for now about this. In other words, how you solve for x. So if I had 7 equals 2 to the x, how can I rewrite that as a log expression? In other words, you're going from here to here.
Log 2 to the y equals 7.
It's not y anymore. It's 7 is what the argument is. That's the argument.
Equals x.
That's the base. That's equal to x. Well, believe it or not, I can go into a calculator and figure out what that is. Calculator has log tables. When I was in high school, you didn't have calculators that could tell you what logs were. And at the back of every math book, they had these big long tables where if you wanted to know what the log base 2 of 7 was, you could look it up. Okay, and now people use their log function on their calculators to figure out what number that is.
Okay.
And it's going to be, like I said, x is going to be somewhere between 2 and 3. It's probably about 2.8, but it is a irrational number always. It goes on and on forever, unless it is a whole number. In other words, when I had 8 equals 2 to the x, that could have been written as log base 2 of 8 equals x, and the x would have been 3, a rational number. So you occasionally do produce rational numbers from logs, just like you occasionally produce rational numbers from square roots. The only time is if what's inside the radical sign is a perfect square number. Every other time you are producing an irrational number. Okay? The secret of logs is to be able to go from that to that. And backward.
Okay.
And backwards. What have I told you this? Log base 3 of 7 equals x. Now, in order to solve this, I actually just go straight to my calculator and solve it. Because I can input log base 3 of 7, and it'll give me a number. But if I started off giving you that, what does that mean exponentially? In other words, you're always switching back and forth between an exponential expression and a logarithmic expression. That's all logs are. So it's just another way to express an exponential expression. So this one down here, how would I express that exponentially?
7 equals 3 to the x.
Yeah. The way I tend to think about it is you take the number on the far left, you take it to the power on the far right, and it's equal to the number, the argument. So the one thing you can now do is go between exponential and logarithmic expressions. And that's valuable to be able to do that. There are some other properties of logs that would take another 10 or 15 minutes to introduce you to, but I'm not going to do it until we run into a problem that requires it. The only thing you need to know is that that could be expressed, first of all, if we let it equal to x, some number, so that's going to be 10 to the x equals 2. Well, you can tell right away that there is no whole number where that is a true statement. 10 to the 1 is 10, 10 to the 2 is 100, 10 to the 3 is 1,000. So this got to be some number between 0 and 1. But it's definitely irrational. In other words, if x is not a precise whole number, then it's irrational. And that's all you need to know for this problem. Is that that's irrational, that's irrational, that's irrational. That's got to be rational. All right, let's go on. Okay, yeah, their terminology is weird. Makes me think that this program might be out of Europe somewhere.
Yeah, I don't really know. Peterson's is the name of the service.
I've worked with a couple of European students, and I've worked with a Russian student, and I was always very curious how they were taught math in their native languages. And it generally comes down to they just use a little different terminology. The math is always the math. They've got to do the same math we've got to do. It's just their terminology is a little different. And there's a lot of IB programs in Colorado that use more of a European nomenclature also. And see, I would never, I teach a SAT class. We don't use the word natural number. We use integers, we use whole numbers, integers, real numbers, rational numbers, and irrational numbers. That covers the whole number line. Natural number, I can only assume that they mean integer, which is a whole number, plus or minus, or zero. Okay, so is there a C and a D on this, or just an A and a B?
I think there's a C and a D. What if we scroll down?
Okay, I can do that. Unfortunately, yeah, no, I can do it. I just gotta. So we're told that N is a whole number. No, they don't have a C and a D. Well, let's see if we can figure out. Let's see if we can figure out which one of these might always be a natural number. Well, what's a good way to proceed?
I would substitute an integer for n.
Exactly.
It could be 1.
So let's let n equal 2. When you are picking numbers like we're going to do here, try to avoid 0 and 1. And the reason is that they have unique properties, those two numbers. That, in other words, you can never divide by 0, so it wouldn't be very good to choose 0 for n, because then we'd be dividing by 0. And 1 happens to be the only number whose reciprocal is also 1. So those two numbers are not good numbers to pick when you're looking to solve a problem by picking numbers. So let's try 2. N equals 2. Well, A would then be 2 over 3. Well, that's not a natural number, if I understand what natural number means. I'm beginning to think I don't. The natural number they're calling might be a rational number, which would be able to be written as a fraction. The problem here is that if n equals 2, then b is 3/2. That's also not an integer, but it's also a rational number. So if natural number meant rational number, both of these would be correct.
Yeah, and actually I'm looking at the study guide, and it's C, which is n squared plus 3n plus 2 over n plus 1.
Like that?
Yep.
Okay. Now, there's a couple things you can do to this. I don't have to just substitute. In other words, finding out that 2 works does not prove this. It says it's always a natural number. So if we were going to prove this was the correct answer, we would have to try 2, 3, 4, 5, basically all the numbers. So there's actually a better way to do this. Factor the numerator. What do you get? How's your factoring? We have not come across a problem yet that we had to factor until this one.
Yeah, I'm needing a review.
Okay. Factoring is another one of those 20-minute lessons. I will tell you on this one that that factors into n plus 1 times n plus 2 without explaining why. Like I said, I don't know if now is the time. Let's see how many factoring problems we come across before I decide that we need to give you a 20-minute factoring lesson. Okay? But suffice it to say that if you were to, you know how to multiply n plus 1 times n plus 2? Are you familiar with the word FOIL?
I am, but again, a review would be good.
Well, I don't even like the word FOIL. I like ET times ET, which means every term times every term. If I multiply that times that, and then I add it to that times that, and I add it to that times that, and I add it to that times that, I get this quadratic that they gave you originally.
Right.
Okay? So that's how you would multiply them together. And factoring is pretty much the opposite of that. So you can imagine that it's not an easy thing to learn, factoring.
Mm-hmm.
Because you basically have to unmultiply it. And there's a system that you can use to do that, and I'll go through that with you if we have to. But once I've factored it, now I can see that that n plus 1 cancels with that n plus 1. And the result of this thing is n plus 2. And that is always a natural number regardless of what n is. And we know it. In other words, I don't have to go through all the numbers, 2, 3, 4, 5, 6, 7, 8. I know that if n is an integer, then n plus 2 is an integer. Okay. And just by using one number only, the number 2, I was able to prove that wasn't an integer, and that's not an integer. So I knew that A and B couldn't be correct. In order to prove something works, though, you can't. In other words, it's much easier to disprove something than it is to prove something in math. Because all I have to do to disprove that is find one number that doesn't produce an integer. And I did, the number 2. Same thing with that. Now you get to number 3, and if I would have tried 2, I would have gotten an integer. I would have gotten 5 as my answer. Or excuse me, 4. If I would have tried an n of 2. But by doing it this factoring way and coming up with that equals this, n plus 2 is always an integer or natural number.
Right.
All right. All right, domain. Domain basically means all of the values that the x variable can take on. Okay?
Okay.
So, how do you figure out? Domain, a lot of times, if I have this equation, y equal x plus 1, what's the domain? It's all real numbers. There is no number you cannot substitute for x. And domain comes down to that. Most functions are all real numbers. But there are some functions where x cannot take on certain values. Okay? This isn't one of them, the one that I've written. However, the one they gave you is x plus 1 over x times x minus 1. Well, when you see a function like this, the only major restriction is going to be on what is in the divisor. In other words, the only rule we know for sure in math, the number 1 rule in math, is you cannot divide by 0. So what 2 values can x not be?
Well, definitely not 0.
Okay, what else? What else would make the denominator 0?
X itself.
1.
Or x plus 1?
In other words, the way when you've got two things multiplied here, I've got x times x minus 1. That whole thing is equal to 0 if either one of those two things is 0, and only if either one of them is 0. In other words, I cannot multiply a times b and get 0 unless a or b is 0. Or if I go a times b times c times d times e equals 0, one of those letters has to be 0. That is one of the most basic theorems of algebra. And it's the whole reason they teach you factoring. Because when they give you a quadratic and they set it equal to 0, you have to factor it so that it is a product of two things. Once you have it as a product of two things, then you can set each thing equal to 0 and solve it.
Okay.
So we know for sure that x cannot be 0 and x cannot be 1. But it can be anything else. It's okay if the numerator is 0. So x could be minus 1. That's fine. The only restriction at all on this whole function is you cannot divide by 0. Which means that's why that's the right answer. It's all real numbers, fractions, positive, negative numbers, but not 0 and not 1.
Okay.
Okay. Another subject that's not particularly, I'll do it as quickly as I can, try to explain it. If you have a linear equation, you have a straight line. Always. That's what a linear equation means. A linear equation would be in the form mx plus b, so you might have something like y equals 2x plus 7. Okay, that's a linear equation. It's going to be a straight line. On this that I just wrote, what's the slope?
2 and 7.
Just 2. 7 is the y-intercept. Okay, in other words, that would be 7. If the line that I graphed is this equation, then that would be 7 and the slope would be 2. Okay, that's what b is y-intercept. M is the slope. Okay, if I take a second linear equation with the same slope, but a different y-intercept at 4, I have a parallel line. You get parallel lines if you have the same slope. So that's simple enough. If they give you two linear equations and they have the same m, they are parallel automatically. Now, what makes two lines perpendicular to one another? If I take my first line and I draw a perpendicular line to it, such that that is a right angle, the one thing I know of this perpendicular line is the slope is going to be the negative reciprocal of the other slope, that it's the line it's perpendicular to. What is the negative reciprocal of 2?
1/2. Negative 1/2.
You got to do two things. Always remember, when you're talking perpendicular lines, you got to do two things, not one. You got to change the sign, and you have to reciprocate it. So it's negative 1/2. I had to make it, instead of 2 over 1, I had to make it 1 over 2, and instead of a plus 2, I had to make it a minus. Just change the sign, whatever it is. Okay?
Okay.
So that's the basic explanation of parallel and perpendicular lines. Okay? Now let's look at this problem. They've given you two equations which represent two lines, and even though these are not in y equal mx plus b format, which is a typical format for a linear equation, the fact is I can solve it, right? In other words, this one ends up being y equal 1 minus x divided by 2. And this one ends up being y equal 5 minus 2x divided by 3. And it's useful to put it into this format because I immediately know the slope. Okay? Now let's talk about this first one. Y equals 1 minus x over 2. Well, that doesn't appear to be in that format, but it's all we have to do is split it up into two fractions. 1/2 minus x over 2. It's the same thing. You can always do that. Split it up into that fraction and split it up into that fraction. And notice that if you were indeed subtracting these two fractions, it has a common denominator. It's going to be 1 minus x over 2. Okay? Now, I can rewrite the positions of these. I don't have to leave it in the number first and the variable second. So I'm going to rewrite it as minus x over 2 plus 1/2. Now I'm getting closer and closer to this format. The last thing I have to do is go y equals, well, this negative x over 2 is actually the same as negative 1/2 times x. And that's important to know also. Well, this gets a lot of students. When you stick that 2 as a denominator instead of as a negative 1/2 coefficient, a lot of students have no idea what to do with that. But that's what you do with it. Is you want to pull out that coefficient. Now this is exactly the same format as that, and I know what m is. What is m?
Negative 1/2.
Okay. So now let's look at the other one. This one, the second equation in item 1. What's the slope on that one? After I separate it into two fractions and switch positions, what's my slope going to be?
5 over 3.
No, that's going to be the y-intercept. Remember, the slope is always the coefficient of the x term. In other words, this becomes, 5 over 3 minus 2/3 x. So there's your slope right there. Well, what do I need my slope to be perpendicular? 2. Positive 2. So that's not right. Okay. Erase some of the stuff I have here. So that's not right. So basically what I have to do on all of these is to figure out what the slope of the first line is and figure out if the slope of the second line is the negative reciprocal.
Right.
All I have to do. Okay? So without wasting 10 minutes, first of all, that one's going to be really hard to do because that is a linear equation. That is not. That's an exponential equation. Your variable is in the exponent. So there's no even finding out the slope on that. That's a curved line. That's not a straight line. So that would definitely be ruled out. We wouldn't even have to try it. Because first of all, we have to have two linear equations. That's not a linear equation. The second one would be. Normally, we would have to check C also to see what its slope is and see if it's the negative reciprocal of this slope. Since we have an answer, yellow, let's go straight to that, just to save a little time. Okay, so let's start with this. Let's figure out the slope of that. How do you do that? Solve it for y. Always try to be putting it into this format.
Right. So we're going to have to subtract x and divide by 3.
This time I'm going to put the x first because that's where it goes, is first. Plus 1. And then divide by 3. Well, that's going to come out to be minus 1/3 x plus 1/3. Whereas I'm doing a couple of steps at the same time there. Okay, so its slope is what?
Negative 1/3.
Okay. Now we got to do the same thing for the second equation. We've got to figure out its slope, and then we'll be able to tell whether they are perpendicular.
Right.
Solve this for y, leaving your format in mx plus b format. That's an x, sorry.
So add 3 and divide by x.
No.
So you'd have...
Well, first of all, we're solving it for y. This is what we want to isolate right there.
Right. So you'd add 2. Oh, divide by 3. I'm sorry.
No. When you are solving an equation for a variable, you want to get rid of everything else. So we've got a minus 3x over here. We got to move that to the other side. How do I do that?
By adding 3x?
Exactly. I'm going to put it in the front. And in one step, we have it in mx plus b format. What's the slope of this?
3. So that is the reciprocal, opposite reciprocal, and would be
opposite
perpendicular.
And that's why D is the correct answer.
Gotcha.
Now, they're a little bit cruel in making it the fourth choice because there's really only one way to do these kind of problems, and that's to go through each answer and figure out the slope of that and the slope of that. Well, they make it a little easier by putting answer B in there because if you recognize that that's an exponential, exponentials aren't straight lines. Exponentials are like this, or like this, or like this. They're curved lines. Curved lines don't have a slope. So when they're talking of a slope on a linear equation, you have to have straight lines. And algebraic expressions do not produce straight lines. So that's why we'd be able to immediately rule that one out, and we wouldn't have to attempt to do the math. Which saves you about 5 minutes, because if you didn't know that, you might spend a long time trying to solve that one for y.
Right.
Wouldn't be easy. In fact, it requires logs. So I don't know what they expect you to do. But eventually you make your way down to answer D and you realize this slope is minus 1/3, this slope is 3. That's 2 perpendicular lines. Okay, so they have taught you a little bit about permutations and combinations.
Is that a question?
Yeah.
Okay. Yeah, I don't know anything about permutation.
Okay, that basically answers my question. Yeah. You have 2 basic things. Permutations. Hold on. permutations and combinations. And the only difference is permutations, order matters. Combinations, it does not. Okay? So, I have the letters A, B, and C. They're basically asking me how many different ways I can write that are different from each other. Well, I got A, B, C. I got A, C, B. That's the only two ways I can start with A. Let's start with B. I got B, A, C, and I got B, C, A. Those are all different. It's the only two ways I can start with B. Let's start with C. I got C, A, B, and C, B, A. That is 6 ways to write the letters A, B, C that are all different.
Okay.
A combination, well, we'll get to that later. I can't really illustrate it with this problem, but that's the way you do it. And you'll notice the way I did it was to start with what you have and then see how many other ways you can write it with A as the first letter. And there's only one other way, A, C, B. Okay? So those are the two ways to write it with A as the first letter. And then I go to B. How many ways are there to write it with B as the first letter? And there were exactly 2 ways there. And the same with C, and that's how you get 6.
Okay.
And that's the way I would presume they want you to do this problem. There is something called NPR. Are you familiar? Have you ever heard of that? And
if I have not in a long time.
CR. Okay. This is for
I think I have.
That's for combinations.
Gotcha.
But this is when it's so large. And in other words, if they would have said, how many ways can you write A, B, C, D, E, F, G? Well, I'm not sure I have enough time to go through them all. It's going to be a huge number. So instead of doing the counting process, which is what this is called, this problem, you could absolutely solve it by the counting process. In other words, by listing all of the different ways you can write A, B, C. However, like I said, if they had 6 or 8 letters in that string, I'd still be writing them and we wouldn't finish. And so you use that to come up with the answer. So this
I think I saw that in statistics.
Yeah, that is a statistics term for sure.
Okay.
And this has to do with factorials and stuff like that. But this is a little complicated in itself. That's probably another 15-minute explanation to explain how you get NPR or NCR. But these are fairly important when you're talking about probability and statistics and even some algebra principles. Turns out that that is key to the binomial expansion, the NCR. So these have lots of uses other than just how many different ways can you write the letters A, B, C.
Right.
When you toss one coin, what's the probability that it lands on heads?
50%. 1/2.
1/2. Well, when you toss both the second coin, or if you toss the same coin twice, the odds that it lands on 1/2 or on heads again is going to be another 1/2. Since both have to occur, you multiply them together. That's all you do. 1/4.
Okay.
If the question was you flip it 3 times and it has to land on heads all 3 times, then it's 1/2 times 1/2 times 1/2, and that's when you get 1/8. So when you're dealing with probability, if both things have to occur, Here, let me give you another example. I've got one coin and one die. Coin has 2 sides, the die has 6 sides. So what's the probability I'll get a heads and the number 4 on the die, both? What's the probability I'll get a heads on the coin?
1/2 times 1/6.
Aha. Probability that I'll get exactly a 4 on the die is 1/6 because there's 6 sides. So the probability that I would get both a heads on the coin and a 4 on the die, I would multiply them both together because they both have to occur.
Okay.
Okay. And again, probability is a big subject, but we'll cover it as needed as we get there. Okay, this sign here means union. That sign right there.
Okay.
Okay. So it's basically saying what is the union of these 2 sets. And I didn't mean to write that as a U. It's more of a U like this. Well, what that means is that all numbers that are in each set, when you take, let me give you an example. If I have 1, 3, 7 in set A, and set B has 1, 4, 8, what does A union B mean? What is in that set?
1, 3, 4, 7, and 8.
Exactly. If I said A intersect with B, what would be in that set? Those are the numbers that are only in both sets.
1 would be it.
That's it. So that's what these things mean. When you take the union, you're taking all the numbers in either set. When you're taking the intersection, which is what the upside down U means, you're taking only the numbers that are in both sets. Okay? So if we look at this problem they're giving us, the first one, if I drew a number line, it would be all numbers to the right of that number line, or to the right of 0, excuse me, with an open circle, not a closed circle. Know the difference between an open circle and a closed circle?
Well, the closed circle is right on that point, and the open would be everything except for that point.
Yes. And it says x has to be greater than 0. So 0 is not in that set. But every other positive number is. Now, this one says all numbers less than 3. So again, it's a circle, but it goes that direction. So when I combine that set with that set, I get all real numbers. There is no number on the number line that is not in one of those sets, including 0 and 3, because 3 is in this set and 0 is in this set. So you get this answer. And frequently, that's the best way to do these problems, is to draw a graph of the number line. In other words, if I had a number line and there's 0 and I had all numbers greater than or equal to 1, that's what that would look like. And combine it with all numbers less than or equal to -1. And that's what that set would look like. Well, if I combine those two sets, it's got all real numbers except from -1 to 1. So this interval right here would not be in the union of A and B.
Right.
All right. Let's look at the next one here, which is a similar. Set theory, incidentally, is what they study when you get done with calculus. Seriously, they give you a little bit of it in lower math. But it's one of those mathematical disciplines like number theory, topology, set theory, matrix algebra. Those are the courses you take after you've taken 3 courses of calculus.
Well, hence why I don't really recognize these symbols then, I suppose.
Exactly, and it's why I don't have a lot of expertise in set theory, is because I only tutor algebra through calculus. And calculus takes you into first year college, so there's plenty of math for me to tutor, but I'm not really an expert on set theory, number theory. I know moderate amounts of both of those, but most of my education came 40 years ago at mine, so I don't remember it unless I've been tutoring it.
Right.
Makes
sense.
Let's see if we can figure out what this means. We're first of all talking about 3 different sets. A union. No, hold on a second. The union is a U. The upside down U is the intercept. So when they say A intersect B, they mean only the items that are in both A and B. So let's say A consisted of 1, 2, and 3, and B consisted of 3, 4, and 5, then C would be just 5. Excuse me, C would be just 3. My apologies. Worst thing a tutor can do is what I just did, because it just totally confuses the student. Is all I'm doing is getting ahead of myself in my head. So I know this. If I have 2 sets and I intersect them, C is going to be only the items that are in both sets. Not sure what that sign means. Do you know?
No idea.
I would assume that it means all the items in A are in B. And the reason that would be correct is because all of the items in C are in B. They're also in A. So I could also write C also happens to be in B. All of the items in C are also in B. So both of these would be correct.
Okay.
But not vice versa. Notice that all the items in B are not in C. I've got 3 items in B. I only have 1 in C.
Correct. Right. So we're looking for, okay, I'm with you.
Okay.
We're looking for including the items in C and either B or A. So that's why that's...
Yeah, what this symbol means is that the items in A are all in B. And clearly they're not. We have a 1 and a 2 that's in A and it's not in B. And we have a 1 and a 2 and a 3 that's in A and only a 3 in C. So the only thing here that even makes sense to do is where C starts. In other words,
right.
C has to be a subset. This thing means a subset. C is a subset of A. And by that, it means it has some of the items in A, but not necessarily all of them. Could have 1, 2, and 3. If C was 1, 2, and 3, then C would still satisfy that. It would be a subset or the same as A. I'm sure that that means it's only a subset and that means it's a subset or identical.
Mm-hmm.
A lot like the greater than or equal signs. You might have to watch time when we're working because I tend to lose track of it pretty easily. When I'm doing math, I am really focused and I'm not even aware of the passage of time. I couldn't have told you whether we've been doing this for a half hour or an hour, but it's close to an hour. So let's see if we can do one more problem here. All right, Venn diagrams, another 30-minute subject, but not that hard. It's basically the graphical representation of what we were just talking about on the previous problem.
Right.
Okay. Subset A has the numbers 1, 2, and 3. I think that's the easiest way to explain it. A equals 1, 2, and 3. I may not be writing that exactly right. But B does have this numbers right here that overlap with A. And I'm going to call that 3. Okay? And in C, only if A combined with B, in other words, if A combined with B equals C, then C only has one number, 3. And the part of C that has both A and B in it is this part right here. In other words, let me use different colors. This has, that's A and B. This is C and A. By and, I mean union. But if I'm looking for what is C, A, and B, it's only this section right here. Excuse me 1 minute, Nathan.
Sure.
Rhonda? Hi, how are you? I am just finishing up a session. It'll be about 2 minutes. Can I call you right back? Thanks, bye-bye. Sorry, I don't normally answer my phone in a session, but since our session was about to be done, I did it. I won't short.
Quite all right.
I'll give you a couple more minutes, but so that's the way Venn diagrams work. Is they overlap only where they have common elements in their set. A typical Venn diagram question, let's just talk about it. You have 200 students in a school. I'll do this really quick. You have 70 that take French. You have 80 that take Spanish. And you have 90 people that take, let's make that 9 people that take, now let's make it 90. Can explain it just a little bit easier, I think. 90 people that take Russian. Okay. Now, obviously, since there's only 200 students and we've got a total of 240 people taking these classes, some of them must be overlapping. You must have some students that take French and Spanish. Okay. But the set of A, this would hold 70 people in it. The whole circle. We're going to let B be the Spanish. That's going to be 80. And we're going to let C be the Russian. It's the whole circle of C. But there's got to be some overlap because we only had 200 students, and we've got 240 taking languages. So if we had, say, 40 students in this area right here that were taking both French and Spanish, then the white area, there's 40 people taking French and Spanish, so there's really only 30 people taking exactly French alone. And there's not 80 people taking Spanish alone. 40 of those people are taking French and Spanish, so there's only 40 there. And now when I refer to the set A, I'm referring to just the white space. So there's 30 French, there's 40 taking French and Spanish, there's 40 taking Spanish only. Well, that's 110 plus 90. There must be 90 students taking Russian only. So my Venn circles would go like this. Here's the 90 taking Russian. Here's the 30 taking French only. Here's the 40 taking Spanish only. And here's the 40 taking French and Spanish. So that's the value of Venn diagrams. It allows you to take complicated problems like that and graphically see them.
Right.
And that's a good place to stop. Let me just see what this problem is going to be. All right. Probably going to ask you to color this in, but this is where we'll begin next time. Is with this Venn diagram problem.
Sounds good.
All right, Nathan. I'll talk to you next time.
All righty. Have a good one.
You too. Bye bye.
Bye bye.